Welcome to my channel. Today we are going to be discussing about negative number representation. So in the previous video I demonstrated to you how do we add binary numbers. So all along when we were doing binary number conversion from decimal to binary, binary to decimal, denary to hexadecimal and so forth, we were dealing with positive numbers. We never dealt with negative numbers. So in this unit specifically we want to discuss about how do we demonstrate negative numbers, because these negative numbers are also numbers, and at some point you'd also want to use negative numbers. Let's say for example you are working, maybe it's minus 2 plus 3 or minus 2 minus 2. These are negative numbers, so you need to know how computers represent these negative numbers. So this is what you are going to be doing today. So we use a process which we refer to as a 2's complement method. They are simple rules, right? I like to refer to them as rules, simple rules that we can use for us to be able to go about representing negative numbers. So the first rule is that you consider the negative decimal number that you are given, you just consider it as a positive. So that's the first rule. For example, if you are given negative 28, you simply say minus 28 is equal to 28. You are making it a positive. So, and then the second rule, you convert the result of stage number 1 into its binary equivalent, right? So I gave you negative 28 as an example, and we said negative 28 would be equals to 28, and then you convert that 28 into binary, right? That is stage number 2. Then stage number 3, you invert the results of stage number 2, right? You invert the binary result you got on stage number 2. By inverting, you simply make all the zeros ones and all the ones zeros, right? The opposite, that's what you do. And then the last stage, you take the result of stage number 3, you add binary 1. That's the last stage. You take the result of stage number 3, you add binary 1. Then you'll have represented your number as a negative. So these are the simple steps that you must follow when representing negative numbers. So there are two ways that we represent negative numbers. So the first stage, the first method consists of the stages that I've just outlined. So in the next video, I'll show you how to represent negative numbers using another method. So let me show you now how do we represent negative numbers using the first method that I've just mentioned. We have got a question which says convert negative 58 to binary. Convert negative 58 to binary. So we have got 4 rules. So the first rule says consider given negative number as positive. That's the first rule. The second rule, it says convert result of stage 1 to binary. Right, convert result of stage 1 to binary. And then the third rule, it says invert result of stage 2, right? Invert result of stage 2 such that all ones becomes zeros and vice versa. And then the fourth rule, which is the last, you add binary 1 to the result of stage number 3, right? Add binary 1 to the result of stage number 3. So now let me show you this in operation. How do we apply these rules? Let me show you these rules in operation. Now, so using those rules, our negative 58 would be equals to 58. That is stage number 1. Then stage number 2, we need to convert 58 to binary. 58 to binary. So 58 is greater than the largest denary number that we can make using a 4-bit binary unit. Therefore, it means we need an 8-bit binary unit to convert 58 to binary. So with an 8-bit, if you are starting from left to right, you start by the largest unit, which is 128 in an 8-bit, right? Or the similar way, as I've always as I've been telling you, you need to start from the right to left. So you have 2 to the power 0, which is 1. 2 to the power 1 is 2. 2 2 to the power 2, it's 4, 2 to the power 3, 8, 2 to the power 4, 16, 2 to the power 5, 32, 2 to the power 6, 64, 2 to the power 7, 128. So these are the 8-bit binary units that we have. So now we need to consider all the units that if we add them together, we will get 58. Let us consider all the units that if added together, they will give us 58. So in this case, 128 is greater than 58, so therefore we switch off binary unit 128. 64 is greater than 58, we switch off binary unit 64. 32 is less than 58, we switch on binary unit 32. And 16, 32 plus 16 is 48. 48 is still less than 58, so we switch on 16. 48 plus 8, it will give us 56. 56 is still less than 58, we switch on. 56 plus 4, it will give us 60. 60 will be greater than 58, so we switch off binary unit 4. And then 56 plus 2, it will give us 58, right? So let me just put the accumulating figures here so that you see. Here we have 32 plus 16, which is 48. Then here 48 plus 8, it will give us 56 here. And then 56 plus 2, it will give us 58 here. That's where we get 58 here. So we switch on 2, then we switch off 1, because 58 plus 1, it will give us 59, which will be greater than 58. So now we have converted 58 to binary. Let us go on to stage number 3. Stage number 3, we simply invert, right? So by inverting, what we are simply doing, we are turning all the zeros to ones and all the ones to zeros, right? So let us invert. Right. So this 0 would become 1. This 0 will become 1. The 1 here will become 0. The 1 will become 0. This 1 will become 0. The 0 will become 1. The 1 will become 0. The 0 will become 1. Like this. Now, the last stage, which is stage number 4. Stage number 4, we said you simply add binary 1 to the result of stage number 3. So this is the result of stage number 3. So stage number 4, you add binary 1. So let us just rewrite this binary number, which is 1 1 0 0 0 1 0 1. Right? 1 1 1 1 0 0 0 0 0 0, and then 1 1 0 0 1. Then we add binary 1 like this. Alright, so 1 plus 1 is according to those rules 0 carry 1. 1 plus 0 is 1. 1 plus 0 is 1. And then 0 0 0 1 1. So this is negative 58 in binary. So negative 58 in binary is equal to 1 1 0 0 0 1 1 0. So that is negative 58. So let us look at another example. Please convert negative 13 to binary. Convert negative 13 to binary. So using those rules, rule number 1, negative 13 would be equals to 13. Rule number 2, we need to convert 13 to binary. So 13 is less than the largest denary number we can make using a 4-bit binary unit. So in this case, we use a 4-bit binary unit. So 4-bit binary units is 2 to the power 0, which is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, 2 to the power 3 is 8. That is our 4-bit binary unit. Now we need to consider all the binary units that if we add them together, they will give us 13, right? So 8 plus 4, 8 is less than 13, we switch on. 8 plus 4 is 12, 12 is less than 13, we switch on. And then 12 plus 2 is 14, 14 will be greater than what? Here we have 12, and 12 plus 2 is 14, 14 will be greater than 13, so we switch off 2. Then 12 plus 1, it will give us 13, so we switch on 1. So therefore 13 to binary is 1101. So stage number 3, we need to invert, right? We need to invert all the 1s to zeros and zeros to 1s. That's stage number 3. So our 1 will become 0, this 1 will also become 0, this 0 will become 1, and this 1 will become 0. And then stage number 4, or rule number 4, we simply add binary 1 to the result of stage 3. So our binary number is 0, 0, 1, 0. We add a 1. 0 plus 1 is 1, 1 plus 0 is 1, 0 plus 0 is 0, 0 plus 0 is 0. So this is negative 13 to binary. That was how we represent negative numbers in binary. Simple 4 stages or 4 rules. First stage, you need to consider that give a negative denary number or negative decimal number as a positive number. Then stage number 2, what you simply need to do, you need to consider the result of number 1, you convert it to binary. It will be easy to convert a positive denary number to binary. And then stage number 3, you invert all the zeros to 1s and all the 1s to zeros. That is stage number 3. And then the last stage, which is stage number 4, you simply add binary 1 to the result of stage number 3. So as simple as that. That's the process. So in the next video, I'm going to show you the second method that we can use to represent negative numbers. It's quite different from this one. It's a shorter one. It's a shorter method, quite different, but it will produce the same answer. So you are going to be dealing with the same numbers. We are going to be dealing with the same numbers to compare whether we are producing the same answers or not. So that is going to be the contents of the next video. So please don't forget to subscribe to my channel. Please share the link. Make sure you like and comment. I do videos for computer science, ICT, and in future I'll also be doing mathematics grade 8 and grade 9. So please make sure you subscribe to my channel, share the link, share to as many groups as possible. My aim is to reach 1,000 subscribers by the end of September. So please help me achieve that goal by sharing. You can get hold of me using my WhatsApp number that is appearing on your screen. You can also contact me on my various social media links provided in the description below. I'm available on WhatsApp, Facebook, LinkedIn, and so forth. So the links are there in the description below. And again, you can get access to other videos that I've done prior to this using links again in the description, right? Because you might just wonder how you just started at converting negative numbers without positive numbers and so forth. So if you haven't watched any of those previous videos, please use the links below in the description below to watch preceding videos to this. All right, thank you very much. See you in the next video.